Hello everyone. While learning HBase, we have seen the introductory concepts in the previous session. Now we shall see how HBase actually operates, how do we indicate the region servers in practicality, and how do we install that, what are the options available with HBase, and how do we go for test drive, and who are the clients available for HBase. So, coming to HBase in operations, initially HBase keeps a catalog. What for this catalog is used? To know how many regions are there and what each region is consisting of, what is the starting row, where is it ending, all such information. This catalog table has a name HBase:meta. We know meta stands for the data dictionary values. So, HBase:meta, within which it maintains the current list, the state and location of all user space regions afloat on the cluster. What do we mean by that? For every region which the user has split the data, that list how many regions are there, in what state it is, what state in the sense not the geographical state, whether it is in active state or recovery state or failure state, what status it is. So, current list, what is its state and the location. Location will be in terms of network address. So, it will try to maintain all that information in HBase:meta. Entries in HBase:meta, that is the metadata in table, are keyed in by a region name, where a region name is made of. So, there are rules for naming conventions, or there are some naming conventions in order to give the region names. Just to see through the how a region name is specified. A region name is made up of name of the table the region belongs to, the region's start row, its time of creation, and finally the hash code of all these things. So, we are trying to maintain all this information. I have just given an example where there is a table called test table, starting row, say for example I have given the identifier as XYZ. So, I will just show you that what are the things we have, what is the table, table name should be specified. So, in my example I am taking it as test table, and what is the starting row of that? XYZ. The next one will be the timestamp. After timestamp, we are going to give a hash key of all this information. How do I know where is the timestamp ending and where is the hash key starting? The hash key value, if you observe, is enclosed between two dots. If you see, the dot is starting here, and once I complete the value, the dot is ending. So, between the two dots, we are trying to embed the hash key value. This is how we try to understand whenever we are seeing this information. So, this is how the regions information will be maintained in the metadata test table, that is the name of the table, the starting row value or the key value for the starting row, timestamp, and then the hash key value. What is the timestamp? Is it exactly day, minutes, hours and so, or sometimes it could be the version number. So, the version number is maintained here and the hash of all these things. Commas delimit the table name, start row and the timestamp. So, if you observe, the first three are delimited by commas. The MD5 hash value is surrounded by leading and trailing period. That is what we have seen. And whenever a write operation is occurring, the writes arriving at a region server are first appended to a commit log and then added to an in-memory store. Memstore is memory store. When a memstore fills, its content is flushed to the file system. It's a kind of batch processing. They will not update every region file for every record that is written. So instead what it is trying to do, whenever at a region server certain write operation is occurring, all the write operations are kept into a commit log, appended into a commit log, and also they are added to the in-memory memory storage. Then once the memory storage is full, the buffer is full, all the data pertaining to those particular write requests will be flushed into the file system. Then the file system will be updated. What could be the reason why we are not doing the update for every write operation? Just to make sure my data is spread across a distributed system and I am not transferring the data across the distributed system for every simple write operation. Instead, let me put it in a log record, and once for every time period, what is the period here? As and when the memory gets full, the data is flushed into the file system. Once for all, this entire batch of writes is posted onto the file system. The commit log is hosted on HDFS, so it remains available through even though a region server is crashing. What is the meaning of this one? Why do I say the commit log is hosted on HDFS and it is remaining available? As I told, whenever we are trying to store the data on HDFS, generally the delete privileges are not available. So once it is stored onto HDFS, the data will be available because the basic nature of HDFS is highly available, high availability. So because of that, we are trying to put the commit log onto the HDFS and it is available even though the actual region server is crashing. When the master notices that a region server is no longer reachable, usually because the server's Z node, that is the zookeeper node, has expired, and it splits the dead region server's commit log by region. On reassignment and before they reopen for business, regions that were on the dead region server will pick up their just split files and not yet persisted edits and replay them to bring themselves up to date with the state they had just before the failure. Try to understand this one, how exactly it is doing. Say for example, I am a region server, I had some commit log. Say for example, there were some 40 write operations. I have a commit log of all that 40 write operations. I kept into the HDFS that commit log of 40 writes. Then the region server failed. What the HBase master is doing, it identified this particular region server failed, but its commit log is not yet posted to the file system. It is still holding it. So what it will do, it will try to see any other region related to this can be reached or not. If not, what it will do is, it will try to see who else is having this particular replica of this particular region server. We know that, right? On the distributed system, replication happens. So which else regions are having replication of this particular region server? In such case, it will try to divide the commit log into regions. Say for example, I have updates on row 1, row 10, row 20, row 40. Just assume. Suppose row 1 and 10 are in region A, row 20 is in region B, row 40 is in region C, and the actual region server was X. So X failed. What the HBase master is doing, it is trying to split the commit log. What is the commit log? Write operations on 1, 10, 20, 40. Depending on the regions where they are available, it will try to split the commit log. So when those regions are ready for doing their business activities, they first see, do I need to update any of the commit logs? If yes, they try to take it from the HBase master, update themselves with the commit log, and they are ready for the activities. How do we install? Download it from Apache download mirror, unpack it onto the local file system. This is how we set the path. Then these are the available options with HBase. Just at the prompt you give HBase, it will show all the options and commands with their description. So these are some of the operations I have listed out. You want to run the HBase shell, you should say HBase space shell. It will open the shell for executing. Likewise. Then let us test whether my HBase shell is working or not. To administer your HBase instance, launch the HBase shell as follows. I told you at the prompt you specify HBase space shell. If it is executing, you should get this information. The version information, when it was installed or when you are accessing that, all this information should come to you, and you should be stopping at the prompt HBase main. This information should be there. This will bring up a JRuby IRB interpreter which had some HBase specific commands. It will, whenever you want to see help on those commands, you can just say help and press the enter key. It will show you the list of shell commands which are grouped into various categories. Now say for example I want to create a table, because we know HBase is a column oriented data store. I want to create a table whose name is test and it has a single column family name data. I want to create that. How do we create? How do we give the command? At this prompt, we remember this is the prompt. We remember this is the prompt. At this prompt, we give create. What is the table name you want to create? Test, comma. What is the column family name you want to create? Data. Just press enter. 0 rows, and it has created in so many seconds. Just like Hive, MySQL, it will show you the statistics of executing the command. It will create the table. Now, just to make sure the table is created, what is the option? If it is MySQL or Hive, we say show tables or list tables. Here we are just saying at HBase, what is the second command you are giving, or second instance? List. When it is listing out, maybe there are some other tables, but the table which we have created should also be shown. And if I want to insert 3 rows into the HBase, with every command, if you see, the command count is increasing. Suppose I want to insert 3 rows. How do we insert? Using put command. Normally for RDBMS, MySQL and all, we use insert. Here we say put. Put the table name. What is table name we are saying? Table test. Which row you are inserting. This is like a row key. And what is the data, first family value, and what value you are trying to give for that first row's family value. Similarly, second row, family count should be 2. What value? Likewise. Now, if you want to see get test comma row 1, what it will do? It will try to show what is the data in first row. 1 row is retrieved. Similarly, you just said scan test. What it will tell? It will try to show just now the user has scanned row 1 and what is the column it is having. When it was created, the timestamp, all that first row information will be available to you. Similarly, second row when it was created, third row when it was created, if I have some 15 rows, all 15 rows information will be shown to us along with the timestamp. After adding, suppose I want to remove the table, just we say disable table. Disable the table name. If you give, the table will be disabled. Once you say this is equal to deleting the rows, after that you just say drop the table name. Remember, in MySQL also, whenever you are dropping a table, before that we generally delete the rows, we need to make it empty. So you are trying to disable the rows and then you are dropping the table. Next time if you list out, the table data will be absent here. And I want to shut down the shell of HBase, stop HBase shell. HBase will be stopped. And what are the clients with which we can interact with HBase? There are basically 3 types of clients: Java API, the default one, and just like you are working with HDFS MapReduce, here also you can work with MapReduce, wherein HBase tables are acting as source of data for MapReduce or sink for storing the results. And what is the other option? REST and Thrift. HBase ships with REST and Thrift interfaces. It will try to work with the remote execution of the data. These are useful when interacting applications is written in a language other than Java. I am not working with Java, but I want to access HBase operations, then it will work with REST and Thrift APIs. So generally these are the 3 possible client applications which we can use, either Java API, MapReduce or REST and Thrift API interface. Thank you.